This is a solution to one of the example Bernoulli equation example problems. The pipe in the figure to the right is transporting oil with a density of 800 kilograms per cubic meter. The velocity at point 1 is 5 meters per second, but at point 2 it's 10 meters per second. Calculate the difference in the height in the two open thin tubes. All right, so I can see from the diagram, I got my little points beneath the vertical pipes, and I got to find the difference in the heights. So here's my strategy. I'm going to use Bernoulli's equation, or conservation of energy, because when I look at this, I see the fluid flowing past. That's a kinetic energy per unit volume. It's got the fluid going up the pipes. That's gravitational potential energy per unit volume. And then the top of the pipes is exposed to the atmosphere, so that's going to be our pressure potential, pressure potential energy. And since we only want to know the difference in the height, and I don't have any of the heights, I'm going to make the height above number 2 0. So I'm going to call that where I'm going to start measuring the heights. All right, let's do the work. So if I look at my givens, I got 5 meters per second under number 1, 10 meters per second under number 2. I've got my height equal to 0 above number 2. And both the vertical pipes, well, they're touching the atmosphere. So that means that the pressure right there at the fluid at the top of each of those vertical pipes is going to be 1 atmosphere of pressure. So if I look at my givens and I kind of list them all out so I can see what I have, you can see I have everything there, and then I'll start with Bernoulli's equation. So I know that the pressure potential energy plus the kinetic energy per unit volume plus the gravitational potential energy per unit volume equals the same at another location because energy is conserved. So looking at this, quickly I can see that my P1 and my P2 are both 1 atmosphere, so they're just going to subtract out. They're going to go away, in other words. H2, I'm making that 0, so that's going to go away. And then this is what I'm left with. And now I see that I have a density in each of these. And since the fluid is non-compressible, the density will be the same everywhere. So I can get rid of all those densities. It's getting smaller. All right. Next, I'm going to move the 1/2 V1 squared to the other side. And then I'm going to do a nice little trick just to make things easier or nicer to look at. I'm going to multiply everything by 2 so I can get rid of those halves on the right. So that'll be 2GH, and then 2 times a half is 1. So that'll be 2GH, and then V2 squared minus V1 squared. Divide both sides by 2G, and put in my numbers and units. And that becomes 100 minus 25 divided by 19.6. And that becomes a really big height difference, 3.82 meters. Those are really long tubes.